Okay, welcome back. So we're going to look at this third form for a quadratic equation. Remember, we've had standard form, vertex form, and now this is factored form. This is really not a common form that you see a quadratic equation or function in. This form looks like f of x equals a. Again, that's still the same a that determines the direction of the parabola, times the difference of x and p times the difference of x and q. If you notice, that is like taking a quadratic function or equation and factoring it into two binomials. That's exactly what you have there. It's telling you that p and q are the x-intercepts. So this is telling you a different thing, where it's going to cross the x-intercepts, okay? It's also called the zeros. And the axis of symmetry can be found by using what p and q equal, adding them together and dividing it by 2. Because the axis of symmetry is cutting that parabola in half, when you graph or plot where those two x-intercepts are, halfway in between is your axis of symmetry. Okay, so let's look at a few of these and see what this means. When you're finding the x-intercept, you are actually setting this equal to 0 and solving. So I'm going to show you number 1 by what I'm talking about when I say it, but then we're just going to use the easier method to do it after that. So if I am setting this function right here equal to 0, I'm going to say that f of 0 equals -3 times -3. Let me rewrite that again. I'm not putting in 0, I'm just setting it equal to 0, so I didn't want to do that. So I just want to say 0 equals -3 times x minus 1 times x plus 2. How do I solve this? Well, I'm going to get rid of the 3 first by dividing by -3. That still gives me 0 because 0 divided by anything is 0, but now I have x minus 1 times x plus 2. To solve for x, I set x minus 1 equal to 0, and I set x plus 2 equal to 0. When I solve, I add 1 to this equation and get x equals 1. When I solve, I subtract 2 from this equation and I get x equals 2. So the x-intercepts are, again, the opposite, so that's 1, 0. And then the opposite, and that's -2, 0. Okay? This was -2 over here. I wrote it really close together. Okay, so you're just going to take the opposite of those. The axis of symmetry is how do you do that? You take your 1 plus your -2 and you divide by 2. 1 plus -2 is -1 over 2. So that's where we would be making the dotted vertical line to show that it's symmetric through that axis of symmetry. Okay, let's do it the quick way now. The opposite of 3, -3, 0. It's the same thing. The opposite of 3 is -3, 0. The axis of symmetry is -3 plus -3 divided by 2. This is -6 divided by 2 equals -3. And that's x equals when you do these because it's an equation. Okay, let's look at the third one. Opposite of -7, that's 7, 0. Opposite of 1, that's -1, 0. Axis of symmetry, x plus -1 over 2, which equals 6 over 2, so x equals 3. Okay, so let's go ahead and let's look at how we want to actually graph one of these. I'm changing this function again like I did last time, and I'm making this the f of x equals x plus 5 times x minus 1. Okay, so when I go ahead and do this, I'm looking to see what is my a. My a is always what's in front of the parenthesis. Nothing's there, we don't say 0, we say 1. It's an understood 1. That means my parabola is going to open up. When my parabola opens up, I am then going to say my axis of symmetry for a minute until after I do my vertex. Or I guess I can do my x-intercepts next. That's easiest. So again, to do my x-intercepts, this is 5. So I do the opposite. It's negative 5, 0. I do the opposite again of negative 1. That's 1, 0. So I have those done. Now from there, let's do my axis of symmetry. My axis of symmetry, you take the negative 5 plus 1 and divide by 2. That gives me negative 4 over 2, which is negative 2. Okay, that is the x of my vertex. Okay, I now take this negative 2, and to get the y coordinate, I'm going to need to plug it in. Okay, so I'm plugging it back into the function. We're going to have to do a couple things here. So we're plugging in and we're doing the f of negative 2 equals negative 2 plus 5 times negative 2 minus 1. Well, negative 2 plus 5 is 3. Negative 2 minus 1 is negative 3. So the f of negative 2 equals negative 9. When I input negative 2, I output, what do I output? I output negative 9. Okay, so I have 2, negative 9 there. Now, I'm going to find my y-intercept. Remember, y-intercept means when I input 0 for x, what am I getting for my y? So that's what I'm going to be determining. Now I'm doing the f of 0. So here I input 0 for x. So I get 0 plus 5 times 0 minus 1. 0 plus 5 is 5. 0 minus 1 is negative 1. So the f of 0 equals 5 times negative 1 or negative 5. I have a y-intercept at 0, negative 5. All right, we'll do our last point at the end. So where do I start? I start at my axis of symmetry. My axis of symmetry is negative 2. That's a dotted line. X equals negative 2. From there, I do my vertex. Well, it goes negative 7, negative 8. So I have to kind of eyeball this. This is my vertex. Negative 2, negative 9. This should be opening up. I have an x-intercept at negative 5, 0 and at 1, 0. We already knew this. This was how we started solving this. This was called factor form, finding the x-intercept. So we saw it was going to cross the x-axis at negative 5 and 1. Now we have our y-intercept is where it touches the y-axis at 0, negative 5. From the axis of symmetry, how many places did I go over? 2. So since I went 2 to the right, I'm now going 2 to the left. This is my other point. My other point is negative 4, negative 5. Now, I have actually more than 3 points. I have 5 points, but that is using factored form. Okay, we're going to quickly do this last one together, and then we'll talk a little bit about all of these forms. Now it says you try. We'll try it together though. F of x equals x plus 1 times x minus 4. A. Again, what's in front of A? Nothing. We don't say nothing. We say A equals 1. Since that is positive, it's going to open up. We will wait and do our axis of symmetry after we do our x-intercepts, because this is the same as x plus 1 equals 0 and x minus 4 equals 0. And our shortcut method said for the x-intercepts, we take the opposite of 1, that's negative 1. We take the opposite of negative 4, that's 4. That's already 2 points that we can plot on our coordinate plane. Okay? Our axis of symmetry, that becomes when we take our negative 1 plus 4 and we divide by 2. -1 plus 4 is 3 over 2, and 3 over 2 equals 1.5. This time, we're going to be going between 1 and 2 when we make our axis of symmetry. Our vertex, to get our vertex, we use our axis of symmetry, what x equals, but then we're plugging it in to our function. And we're doing f of 1.5 equals 1.5 plus 1 times 1.5 minus 4. 1.5 plus 1 is 2.5. 1.5 minus 4 is -2.5. When you multiply these, you might need your calculator, you get a -6 1/4 or 6 25/100. So when we plot that, we're going to be a little below -6. Our y-intercept, remember y-intercept is when you plug 0 in for x. So f of x equals 0 plus 1 times 0 minus 4. 0 plus 1 is 1. 0 minus 4 is -4. The f of 0 equals -4. So we have when x is 0, y is -4. Let's go ahead and plot this one. I told you that this time my axis of symmetry is in between. So you're just going to do your best job to go in between 1 and 2 and draw your dotted line. Okay, when we do that, we get x equals 1.5. From there, we're going to do our vertex. 1.5, -6.5. It better be on this axis of symmetry, and it is. And it's just a little bit below 6. So it's 1.5, -6.5. That's our vertex. Then from there, we're doing our x-intercepts. -1, 0 is on the x-axis. 4, 0 is on the x-axis. What is our y-intercept? Our y-intercept is 0, -4. Okay. How far did we go to get from this axis of symmetry? We went a half and a whole. So on the other side, we're going the other half and a whole. And what is that giving us? That's giving us the point 3, -4. So we have that point, that point. These are all my points, making my parabola. And I bring it up like that. So that other point was 3 on the x, -4 on the y. On the bottom here, it says note for all quadratics. If you can find the vertex and one point, you can sketch the graph because your other point would be symmetric to the other side of the axis of symmetry. So we have learned 3 different methods for graphing a quadratic. The standard, when a quadratic's in standard form, which is what we did last lesson. Today we've done vertex form and we've done factored form. I am not expecting you to know this factor form. From here on out, for the rest of our studies for quadratics, you will either need to use not factored form, don't want to highlight that, you will use vertex form, so be very familiar with that one, or you will be using standard form, okay? Today's classwork assignment, you were using standard form. So make sure you did that on the 2 problems you chose to do. For the homework tonight, you will be using vertex form, okay? Please remember that I have my virtual office hours each morning from 8 to 10, and I can help you out so that you can work through these if you need help, okay? So please reach out to me if you do need help, and I hope you have a good rest of your day and that we'll be able to see each other soon. All right, bye-bye.